So long-term effects of the vaccine, I can certainly understand why people are concerned about this particular question. What is most important to understand from all of the physicians I've talked to and from the infectious disease expert I've talked to is that we know some of the long-term effects of the COVID-19 infection, which include blood clots, really severe chronic fatigue, senses of taste and smell not coming back, enlarged hearts, overall inflammation. We know that those things exist in patients who get COVID. And in general, when a vaccine is developed, if there are going to be side effects, which they are usually very, very, very mild, they will show up within the first month after vaccination. So these trials have gone on now for several months. So the people who develop these vaccines are confident that the long-term side effects are going to be non-existent, if not very, very mild. This was an interesting question. So if you've gotten coronavirus, you probably do have some immunity going forward. It's important to remember though, if you've gotten the virus, that you can still transmit the virus, even though you're not getting sick. It's also probably likely going to be that revaccination will be required or recommended, but that determination has not been made by the FDA or by physicians at this point in time. So those studies are yet to be done. This is an interesting question. Like, why did these vaccine designers go after that good old spike protein we talked about in episode 1? So if you're not familiar with episode 1, spike protein, you've heard of it in the news. It's shown on this little COVID meme virus as this blue little protein. Now, when they're designing a vaccine, they're looking for a protein that is on the virus that can do two things. That protein has to both lock onto one of your cells and essentially open your cell so it can get in, okay? Now the spike protein can do both of those two things. Maybe this red protein, it might be able to lock onto your cell, but it can't get itself in. So that's not a good target for the vaccine. So we're going after the spike protein because it can get on your cells and it can get in your cells. The vaccine causes your immune system to make antibodies against this spike protein. So those antibodies that you're gonna make will look something like this awesome scientific drawing here. Okay, these are antibodies. I'll just abbreviate that AB for antibody. Now, it's important to know that this vaccine is going to, or supposed to, make your immune system make a whole bunch of these antibodies that are of a specific kind. They're called neutralizing antibodies. So hang with me here because now we're getting into science. These neutralizing antibodies do just what it sounds like. When they see the coronavirus itself, they will cover all of the spike proteins on that coronavirus and they will neutralize the enemy. They will cover all of these proteins so now this virus basically has its hands tied. It can't attach to your cell anymore and it can't get in. And so that's why they targeted that spike protein. So when you get this immunization, you need to be able to make a whole bunch of the neutralizing spike antibodies. Okay, and then we're not sure how long these antibodies are going to stay around. So there's a good chance that this vaccine is going to be something that you get yearly. Okay, and then another question that kind of goes along with this is, should I get this vaccine if I've already been infected? Well, they're probably going to recommend that you do that just because if you've been infected in July, your immunity is probably going to wane by the winter time and next spring. So they may recommend that you get that again. Boy, guys, so this question really kind of threw me this weekend when I saw this article that had been shared on social media about the idea that this vaccine may cause sterilization in females. It threw me because I'm a mother of a young baby too, and the idea of causing sterilization is terrifying. So I read through it and immediately kind of had some of my own questions about the source of the article, the scientists quoted in the article, and then set up some red flags as far as the science for me. I did some more research on my own, and I'm so glad that I read that because I learned something from my research and from talking to some experts. So here we go. The scary thing is that there's a protein on a placenta. So here's my happy mom. I gave her arms now. And this is the placenta. For those of you that don't know, a placenta is an organ a mom makes every time she gets pregnant, which is pretty cool. Moms are superwomen. So the placenta itself has some proteins on it. So I drew over here. Here's my little placenta, and here is this green is a protein. Can you see it okay?
Yep.
Okay. The green protein is kind of like a mountain shape. Now obviously you guys, to make these videos, we're kind of simplifying some science here. But generally this idea is true. This protein has a unique shape. So this syncytin-1 protein, I kind of have to struggle with that. Syncytin-1 protein, that's what's on the placenta. Okay, now remember, the COVID vaccine, if you watched episode 1, it helps your body to make antibodies to the spike protein. Here's my SARS-CoV-2 virus that causes COVID-19. Here's the spike proteins. Spike proteins also have a special shape. The shape of the spike protein and the shape of the syncytin-1 protein, they're different. So the antibodies that you're going to make when you get the COVID-19 vaccine, they have a specific shape. That shape is unique to the spike protein. These spike protein antibodies won't fit on the syncytin protein, so they're not going to cause any damage. Now, it is fair to say that we don't know a lot about how this vaccine will work in pregnant women, because pregnant women were not included in these studies. And that's why the FDA is probably not going to authorize use of this vaccine for pregnant women. However, if getting COVID-19 would cause miscarriages, we would have expected to have seen women who had COVID-19 infections right before they got pregnant, or who got COVID-19 early in pregnancy. We would expect to see higher rates of miscarriages in those populations. We don't see that so far in the data. Okay, so I hope that helped you understand and kind of debunk some of the claims in that article. It's also important to know the syncytin-1 protein that's on the placenta is really only similar to the spike protein in that they both cause viruses to fuse to your tissue, and that's about where it stops. Their shape is different, they have different functions. Hope that helps.